1. Let's start looking at Chapter 1. There is a lot of pre-cal in Chapter 1, folks. Okay, we will definitely learn more about our calculators and how to use them, more ways to use them. And we're going to learn a lot just about properties of functions and some basic functions. I'm trying to think what else is even in Chapter 1. But there's some review of algebra. But, we're also building and growing here. So, Lesson 1 is modeling and equation solving. So, we're going to look at how to model problems or whatever. We're going to use numerical approaches, algebraic approaches, and graphic approaches. Okay, so mathematical model. A mathematical structure that approximates phenomena for the purpose of studying or predicting behavior. So basically we're looking at various data and different ways to study it. Okay, the first one we're looking at, numerical model, the most basic kind of a mathematical model in which numbers are analyzed to gain insights into phenomena. So just studying the numbers, okay? So example 1. The numbers in the table to the side show the growth of the minimum hourly wage from 1955 to 2005. The table also shows the minimum wage adjusted to the purchasing power of $1996. Answer the following questions concerning the data. Okay, so you've got years over there, minimum hourly wage, and purchasing power $1996. A, in what 5-year period did the actual minimum wage increase the most? What do you think, Jacob?
1995 to 2000.
Let's see. You said 95 to 2000.
Yeah. It went up by like 90.
It went up by 90 cents. There's actually something bigger there, which is what I was double checking. I agree, from 95 to 2000, it went up by 90 cents, but there's one that's slightly bigger.
75 to 80.
Yeah, from 1975 to 1980, what did it go up? $1 instead of just 90 cents, right?
I didn't see the other thing.
You just assumed it went from 210 to 210 or whatever since you just saw the 10 in there?
Yeah. I didn't care about that year again.
I get it. Okay, so officially I'm going to write down 1975 to 1980. Look at your data carefully, right? Okay, B. In what year did a worker earning the minimum wage enjoy the greatest purchasing power? So when did they get the most out of their dollar, I guess?
Was that like 1970? Is that what the numbers be?
Mm-hmm. Yeah. 1970, because in 1970, the purchasing power was $6.47. Okay. So, I don't know. I'm not the econ teacher. I don't know exactly how to put that into words, but you're getting more out of your dollar when that purchasing power is $6.47 than when it's $4.15 or something. Okay. So 1970 there. What was the longest period during which the minimum wage did not increase?
2005.
Yeah, so based on what's shown here, 2000 and 2005, which is a total of how many years? 5 years. Now, we technically don't know, well, what was it in 1999 or what was it in 2006, right? So it could be longer, but based on the information we have here, I'm going to say 5 years. And that was from 2000 to 2005. A worker on minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970. And yet there was great pressure to raise the minimum wage. Why? So in 1980, minimum wage, they were earning twice as much as 1970. However, there was a lot of pressure still to raise the minimum wage.
Would it be because the purchasing power went down?
Yeah. During that same time period, even though, sorry, I gotta find my right spots here. even though there's a big increase in minimum wage, that purchasing power was going down. So even though they're earning more, they're not getting more out of their money. Does that make sense? Okay, and the whole point, you want to be able to do more there. So that is exactly the reason, though, is that the purchasing power was decreasing. Okay. Easy enough reading a chart there? All right, that's just looking at, numerically, looking at numbers. We've got one more example here. And this, so we're looking at a table again, but I'm going to teach a different method to look at this. The table to the side shows the growth in the number of prisoners incarcerated in state and federal prisons from 1980 to 2005. Is the proportion of female prisoners over the years increasing? So notice a key phrase there. Proportion of female prisoners. And I guess specifically we want to talk increasing, right? Is that the same as asking, is the number of female prisoners increasing? Not exactly, is it? That's slightly different than asking, is the number of female prisoners increasing? Because as you look at that list, is the number of female prisoners increasing? Yes. But we're asking, is the proportion of female prisoners increasing? So what do we have to do to figure out the proportion? In respect to what, though? The total, right? If we're looking at the proportion of female prisoners, we're going to look at the number of female prisoners in respect to the total number of prisoners. In other words, the males mean nothing to us right now, okay? I said that way wrong, and don't come back and bite me on that one, okay? But, the information on males is irrelevant in this question. What we're going to be looking at is the females in respect to the totals. So in order to find the proportion of females, what I would say is to do the females divided by the total amount. Now, one option, and it's going to be the quicker option because it's what you know how to do, is to take your calculator and just divide each of those, right? I want to show a technique, and again, it's not quicker right now because you don't know what you're doing, but once you know what you're doing, it's quicker. Does that make sense? Or it can be. So I want to show something called list. So you guys all have your calculators, right? I'll put my calculator up here. And what we're going to go into, the stat button, which is 2 over from alpha. Hit the stat button for me. And it brings up a menu that looks like such, right? So I hit stat. And then it's right now it's on number 1, which is edit. So the easiest way for me to do this is I'm going to go into number 1 and I'm going to hit edit. Now, this is my calculator, and obviously I've used this before. You may have some numbers in your list, yes, or your list may be empty, depending on whether or not you've used this function. I'm assuming a brand new calculator would be empty, but I have some numbers in my list, right? So first thing before I do this is I want to delete these numbers. Now, I can delete a number by number, or if you want to clear out the whole column, I'm not going to use the word delete. You want to clear out the whole column. If you go up to the heading, so if I go to L2 and hit clear and enter, it will clear everything in the list. Do not hit delete up there or you'll delete the whole list, or you'll delete the whole column so it doesn't exist. Okay, so if I go up to, or I can, if I want to delete individual entries, I can delete individual entries. But if you want to clear out the whole column, you can clear out the whole column. Okay, now, so your column's empty. I guess it wouldn't have to be empty because you could just use 2 others. So in my L1, I'm going to put, I don't know, let's go ahead and put the females in L1. Does that work? So in L1, type your female numbers. You guys can figure out how to do that, right? 13, enter. I don't know what I just did. I must have been in the wrong place. There we go. 23, enter. 44, 68, 93, 108. So did you guys put those in L1? I mean, here's the deal. You have to keep track. What numbers are you putting in what columns? Now, what's the other piece of information we need for this particular problem? We need the totals. So I'm going to go ahead and put my totals in L2. So arrow over, 329, 502, I'll quit talking. Make sure you type the numbers right. I know I haven't skipped over any numbers, or at least I likely haven't skipped over any numbers if both lists have the same number of numbers, right? Is that a good way to think about it? Always an easy thing to check. Now, what do we want to know? What is it ultimately we're trying to find? We're trying to find the proportion of female prisoners, right? So we're trying to find and respect the females divided by the total amount of prisoners. So what I'm going to do is I'm going to go over into L3 now, okay? And what we're going to do is we're going to set up a formula, an equation, so that it will do all the math for me at once. So I'm not going through and typing in each set of numbers. So if I go up in here to L3, notice I'm up in the heading, right? We want to take the women divided by the total. Females divided by total. Where are females? L1. So we're going to type L1. Now, look above your number 1 on your keypad. You see the little blue L1? Mine's blue. How do we get a blue thing to happen? I'm going to go second and number 1. And that types in an L1. Does that make sense? And then I'm going to do divide by. And what do I want L1 to divide by? The numbers that are in L2. So L2 is right above 2. So I'm going to do second and L2. And when I hit equals, if you've done this correctly, I just got all my numbers at once. And they're a nice little chart, and you can easily see what's happening with these numbers. Are they increasing? Are they decreasing? Are they all over the place? What are they doing?
I don't know what I did, but
Okay. That happens. So go up into L3. Be in the heading. Now type it.
That's what I did.
Yeah. You have to be in the heading because we're going to use the whole column divided by the whole column. Okay? Did it work that time?
Yeah.
Yeah. If you didn't work, one of the big things is you might not have been in the actual heading. You might have just been in the first spot. Okay. So I'm going to write down information, obviously, but is the proportion of female prisoners over the years increasing?
Yeah.
Yeah, are my numbers increasing in L3? We've got and really, if we wanted to change these to percents, we could have put a times 100 in our formula. I didn't worry about that because I can still see, the proportion as a decimal. But basically, we've got 3, almost 4%. Then it's 4.5%, 5.5%, 6%. A little over 6.5%, 7%. Those numbers are continually going up, aren't they? So my proportion is increasing. Now, if you want a reminder, we went into stat to do that. Okay. So if you want a reminder, this is in stat. It's the list is what it is. And then in L1, we put the females. And I'm not going to write all those numbers because they're right next to us. In L2, we put the total. Again, not listing all those numbers because we, you know. In L3, what did I type? I typed that I wanted to do L1 divided by L2. And I got the following numbers. 0.03951, 0.04582, 0.05685, 0.06044, 0.06686, 0.07077. Okay. And off to the side, I'm going to say, you know, I'm going to say yes, and I'm just going to say as shown in L3. Okay, write down what you want to write down. Obviously, as I said, was this quicker this time?
No.
No, not at all, right? You did it, you would have had it done way before I even started teaching this. However, it's a helpful tool that your calculator has that you can use. Okay, given two lists of numbers, you know, you can get to do the calculations for the list of numbers all at the same time. Then they're all there in the chart. You don't have to write them down or anything. I always, if I'm in something, I want to get back to something, I always do second quit, which is right above mode.
Cool.
If I'm stuck in somewhere and I can't get out, does that make sense? That's a good question because that's one that I think a lot of people, I don't know if there's a better way to do it, but I'm stuck in here, I want out of here, I'll do a second quit. I know some people just turn their calculators off.
Yeah, that's what I'm used to.
Sometimes when you turn it back on, it goes right back.
It's still in there if you don't leave it off long enough, maybe. Yeah. So that's what I do. That's my suggestion. Okay? Okay. That's numerical models. It's just looking at the numbers, analyzing the numbers. And as I said, I wanted to teach you the idea of how you could use the list function on your calculator. Okay? We're using list there. So, okay. We're going to talk about algebraic models. A mathematical model that uses formulas. Okay, when we're talking algebraic, we're talking there's an equation, there's formulas involved. To relate variable quantities associated with the phenomena being studied. It can then generate numerical values of unknown quantities by relating them to known quantities. So, let's flip back to example 3. Dang it, I hope no one's hungry. Because this problem's not going to help, is it? Okay. A pizzeria sells a rectangular 18 by 24 inch pizza for the same price as its large round pizza with a 24 inch diameter. If both pizzas are the same thickness, which option gives you more pizza for the money? So it's a better buy question. Which one's the better buy? They're the same thickness, different shapes with their individual dimensions. Thoughts of how we can do this?
Find the area.
Compare areas. Okay. Because if they're the same price, it's okay. Where are you getting more pizza for your money? If they were different thicknesses, I'd want to talk volume. But since the thicknesses are the same, we don't have to worry about that. So, let's see. We have a rectangular pizza. What do you know about the area of a rectangular pizza? Length times width. So, in this case, we're going to do 18 by 24, which is 432 square inches, if you will. And then we have a, in their words, round pizza. Well, what are you thinking round? Okay, so we got to talk circle. What's the area of a circle? Is that the stuck part? Yep. Pi r squared. And folks, you're at a stage in your life, it's good to know that formula. And I know a lot of you have an idea of it, but know it for sure. So, you can use your pi button, or you can use 3.14. I guess I should have asked, what is pi? 3.14, right? I don't think I needed to ask, but what's r? 12. R is the radius. They didn't give me the radius, though. They gave me the diameter, and half the diameter is the radius, so 12 squared. Do the math. 3.14 times 12 squared.
Here's my pi button. There.
And whereas pi is above your exponent button. And you can do pi button times 12 squared or 3.14 times 12 squared. You'll get a slightly different answer, but it doesn't matter for this purpose. What are you guys getting?
452.3893421 or 452.16.
Okay, so if you did just the 3.14 times 12 squared, you got 452.16. If you use the pi button, it was 452.39 approximately.
Yeah.
Honestly, does it matter? It doesn't matter for the purpose of this problem because what do we know? Yeah, the round one is bigger, isn't it?
Yes.
If they're the same price, you're getting more pizza with the round pizza. So I'm not going to, I think it explains itself here. I'm just going to write down round pizza. Okay. Easy enough? I was thinking we had another algebraic, but we don't, do we? That takes us into graphical. Okay. I don't know that we'll fully get through example 4, but it's like too early to just quit. So we're going to do what we can of example 4, and we have to pick up awkwardly tomorrow, then so be it, right? Okay, so graphical models. Obviously, can I say obviously? A graphical model is looking at a graph, right? A mathematical model gives a visual representation of a numerical model, or an algebraic model that gives insight into the relationships between variable quantities. Okay? Now, the example we're looking at here. Galileo spent a good deal of time rolling balls down inclined planes, carefully recording the distance they traveled as a function of elapsed time. His experiments are commonly repeated in physics classes today, so it's easy to reproduce a typical table of Galilean data. Now, the question on this one is what graphical model fits this data? And then what we'll do is once we kind of look at the graph, we'll talk about an algebra, what algebra equation or model represents that. Now, you still have your calculators there, right? Okay. Grab those calculators. As I said, we may end up in a funky spot, but we're going to look at how you can, okay, so you have all those ordered pairs, right? Can you tell by looking, just by looking at those numbers, what shape that graph is going to form? Is it a line? Is it a parabola? Is it a cubic? Is it a squiggle? Is it a snake? Is it a V? Can you tell by looking what that's going to look like? Just by looking at the numbers. I'm going to say probably not, right? You can probably graph them and look and kind of figure out. Now, how precise of a graph can you get by doing that by hand? Probably not very. So, this is where we're going to look at how you can graph ordered pairs on your calculator. But we have to use something called stat plot. Now, before we do that though, we need these numbers in our list. So you know how I just showed you how to do a list? We're going to go back into list. We're going to clear out the numbers we had in there earlier, and we're going to put these numbers in. Okay? So when I get in there, I'm going to put my top row of numbers in L1. I'm going to put my bottom row of numbers in L2. Now, if you really want, could you use L3 and L4 instead and leave L1 and L2 where they are? You could. Okay, I'll show you how to adjust that when we get to the graph later on. So, remember the button I'm going to use to get in here is Stat. Then I'm going to just hit Enter to go in here. Now, I want these numbers out of my list. Listen carefully. You can delete individuals or you can clear a whole column, right? Just deleting a column is bad.
Okay, so how do you end up accidentally deleting the column?
If you go up into where I'm at right now, L1, if I hit delete, it's going to delete L1 to the point where I have no L1 column.
Oh.
Now, it's possible to get it back, but I don't remember how off the top of my head. I'll be honest. I have to figure it out usually about once a year. I have to figure it out because someone does it. Huh? I guess you probably could reset the calculator. I just don't think about that. So, nope, I'll do clear enter. Okay, so did you guys put your numbers in? Oh, that's about all we're going to get done, isn't it? How did those last minutes go so quick? Well, we'll have the numbers for tomorrow. So L1 is 0 through 8. Did you put in 0? L2. I'm just typing in the numbers as I go. Okay, kind of check, make sure, did you enter all the right numbers? My columns are the same length, so that makes me feel confident that I didn't skip any numbers. But what we're going to look at tomorrow is how we can graph, so how we can get these dots to show up on our graph. You know, our graph where we usually have the lines and all the equations? How can we get dots to show up? And as I said, we're going to use something called stat plot. However, we're out of time. So we will work on that tomorrow. Okay? Homework is up there. It's also on Schoology and Skyward. It's on page 74. You're welcome to look at it. I don't know, it's probably minimal what you can actually go ahead and do on it, though.
So on that chart, it says 51 as well, right?
It does. I need to rewrite that because that didn't work out very well. Yeah, it's 11, 12, 14, 20, 21, 23, 30 through 36 even, 40 through 46 even, and a random 51 thrown at the end.